March 5, 1945. Inside a barbed wire enclosure on the volcanic ash of Iwo Jima, a Japanese lieutenant colonel stood with his hands gripping the fence, watching something that made his legs weak. American construction workers in Navy uniforms were building a road up the side of Mount Suribachi. Not planning it, not surveying it, building it. With bulldozers and graders working in continuous shifts, carving switchbacks into terrain his own engineers had declared impossible to traverse. The prisoner's name has been lost to history, but his words were recorded by Marine Lieutenant Howard Connor in a unit report dated March 9, 1945. The Japanese officer had tears running down his face. "For 20 years, he said through the interpreter, we tried to make a road to the top. You did it in 2 weeks. Lieutenant Connor, who witnessed the exchange, wrote that the prisoner wasn't expressing admiration. He was describing the moment he understood Japan had already lost the war. Not because of American carriers or bombers or Marines, because of men with bulldozers who could accomplish in days what Japanese military engineering doctrine said required months. The American construction workers the prisoner was watching were Seabees, members of the United States Navy's construction battalions. The 31st Naval Construction Battalion had landed on Iwo Jima on February 19, 1945, the first day of the invasion. By March 5th, just 14 days later, they had completed a fully operational road to the summit of Suribachi that included proper grades, drainage, and an oiled surface to control dust. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand why this moment shattered a Japanese officer's confidence in ultimate victory, you need to understand what military construction meant in the Pacific War, and how fundamentally different the two sides approached it. The difference wasn't just in resources or industrial capacity, though those gaps were enormous. The difference was philosophical, rooted in how each military conceived of engineering itself. December 28, 1941. 21 days after Pearl Harbor, Rear Admiral Ben Morrell sat in his office at the Bureau of Yards and Docks in Washington. As the Navy's Chief of Civil Engineers, he faced a crisis that would determine whether America could fight a two-ocean war. Civilian contractors had been building naval facilities across the Pacific, men who knew construction but wore no uniform and carried no weapons. Under international law, these civilians couldn't resist enemy attack without being classified as guerrillas subject to summary execution. Wake Island had proven the vulnerability of this system. When Japanese forces captured the atoll on December 23rd, they took more than 1,200 civilian construction workers prisoner. 98 of those men would later be executed. Similar captures occurred throughout the Pacific as Japanese forces swept across island after island during those first months of war. Morrell proposed something unprecedented: a military unit composed entirely of skilled construction workers, men with trade experience, who would be trained by the Marines in ground combat. They would be both builders and fighters. The Navy approved his request on January 5, 1942. The 1st Construction Battalion was commissioned at Camp Allen, Virginia, on March 5, 1942. The men who volunteered for these new construction battalions brought skills that military training couldn't teach. They were the men who had built Boulder Dam during the Great Depression. They had poured concrete for New York's skyscrapers, dug subway tunnels, constructed bridges, operated heavy machinery in mines and quarries. The Navy specifically sought out carpenters, electricians, steel workers, equipment operators, concrete specialists, and demolition experts. Because they needed skilled tradesmen immediately, the Navy waived normal age restrictions. The average age of early Seabees was 37 years old. Some men over 60 managed to enlist by lying about their age. These weren't fresh-faced kids learning to fight. These were experienced professionals who knew dirt, drainage, and the properties of materials under stress, and who were now learning to work under fire. The construction battalion designation quickly became abbreviated as CB, which sailors phonetically rendered as Seabee. The name stuck. By the end of 1942, 51 CB battalions existed, with 3/4 already deployed overseas. Their official motto was Construimus Batuimus, we build, we fight. What made the Seabees revolutionary wasn't just that they were armed construction workers. It was that each battalion was a completely self-contained unit, capable of building anything from scratch, with no outside support. A standard battalion comprised 32 officers and over 1,000 enlisted men organized into 4 companies. Every essential construction trade was represented within the battalion's own ranks. They brought their own equipment, their own supplies, their own medical personnel, their own administrative staff, their own mechanics to keep the equipment running. The equipment lists read like inventories from major construction firms. Diesel tractors, bulldozers, carry-all scrapers, motor graders, power shovels, heavy rollers, concrete mixers, air compressors, rock drills, cargo trucks, trailers, asphalt equipment, rock crushers, drag lines, and pumps. A single battalion could independently construct an entire airfield with runways, taxiways, fuel storage, maintenance facilities, and supporting infrastructure. Training was comprehensive and brutal. After 3 weeks of basic military training, Seabees underwent 6 weeks of advanced instruction at staging facilities in Davisville, Rhode Island, or Port Hueneme, California. They learned to operate every piece of heavy equipment. They studied soil mechanics and drainage principles. They memorized the load-bearing requirements for different aircraft types. They practiced construction under blackout conditions. They learned to work wearing gas masks. They trained to defend construction sites against infantry attacks. Most critically, they learned to work fast. Speed wasn't a preference, it was a requirement. In the Pacific, an airfield that arrived 2 weeks late might arrive after the battle had already been lost. The Japanese military approached construction entirely differently. The Imperial Japanese Army and Navy had separate engineering organizations that didn't cooperate and sometimes barely communicated. Army engineers were designed primarily for continental warfare against the Soviets, building fortifications and repairing roads for infantry operations. Naval construction units could build bases and airfields, but they were relatively small, lightly equipped, and dependent on manual labor. Japan had power rock crushers, concrete mixers, and mobile drilling equipment, but bulldozers and power shovels were in desperately short supply. Japanese military budgets in the 1930s had prioritized warships, infantry divisions, and aircraft. Construction equipment received minimal funding. When Japanese forces needed to build airfields in captured territory, they relied primarily on picks, shovels, and human muscle. Japanese planners had one reasonable justification for this approach. Their aircraft were lightweight compared to American planes. A Japanese Zero fighter weighed about 5,000 pounds empty. Most Pacific Island soil could handle that weight without requiring heavily engineered runways. Graded dirt or crushed coral, properly compacted, worked adequately for Japanese operations, but this meant Japanese construction was labor-intensive and slow. When the Japanese began building the airfield on Guadalcanal in July of 1942, they employed over 2,500 workers, including 2 large construction crews supplemented by local forced labor. The plans called for a single runway with basic facilities. Construction was ahead of schedule when American Marines invaded on August 7th. The Marines captured the nearly completed airfield and immediately renamed it Henderson Field in honor of Major Lofton Henderson, killed at Midway. What happened next revealed the fundamental difference between Japanese and American engineering philosophy. The Marines found Japanese construction equipment abandoned at the site. Steamrollers, a few trucks, hand tools. They put it all to use. Then the 6th Naval Construction Battalion arrived. Within days, the Seabees had not only completed the runway to standards that could handle heavier American aircraft, they had begun expanding the entire complex. They filled bomb craters, built drainage systems, constructed fuel storage, erected maintenance facilities, and kept the runway operational despite daily Japanese bombing raids. Japanese forces discovered they couldn't destroy with bombs what the Seabees could repair in hours. August 17, 1942. Guadalcanal had been in American hands for 10 days. Japanese commanders in Rabaul were receiving reports they didn't believe. American pilots were flying combat missions from Henderson Field. The airfield that Japanese construction crews had spent weeks building was not only operational, it was being expanded at impossible speed. How could the Americans be working faster on captured enemy territory than Japanese forces could on their own bases? The answer involved a technology that most Japanese engineers had never seen: pierced steel planking, universally known as Marston Mat, after the North Carolina town where it was first tested. This innovation would transform Pacific warfare. The concept emerged from necessity. Traditional airfield construction required either concrete, which took weeks to cure, or compacted earth and crushed coral, which turned to mud in tropical rains. Concrete was too slow, dirt was too vulnerable. The American military needed something fast, durable, and transportable across thousands of miles of ocean. Carnegie Illinois Steel Corporation in Pittsburgh developed the solution. Engineer James Marston designed interlocking steel panels, each 10 feet long and 15 inches wide, made from 3/16-inch high-strength steel. Each panel weighed 66 pounds, light enough for 2 men to carry, strong enough to support the heaviest bombers when properly installed. The genius was in the design details. Rows of holes punched through each panel reduced weight by 30%, created natural drainage, and provided tire traction. One long edge had a raised lip with a hooked end. The opposite edge had a corresponding channel. When placed side by side, the hook slid into the channel and locked mechanically. No bolts or welding required. The connection was strong enough to support a 50,000-pound aircraft rolling across the seam, yet flexible enough that the entire surface could conform to uneven ground without breaking apart. The system worked on a principle of distributed loading. When a bomber's landing gear touched down on one panel, the interlocking mechanism immediately transmitted the force to adjacent panels. By the time that concentrated weight reached the ground underneath, it had spread across roughly 100 square feet of matte surface. Soft soil that would collapse under direct aircraft weight could easily support the distributed load. Testing in Louisiana swamps in March of 1942 proved the concept. Engineers laid 1,200 square feet of Marston mat directly on unprepared waterlogged ground. They rolled a fully loaded B-17 across it 50 times over 3 days. The mat flexed visibly as weight passed over, but held without structural failure. The ground beneath compressed about 2 inches, but the interlocking system distributed that compression evenly across the entire surface. The military ordered 60 million square feet immediately. By late 1942, American factories were producing Marston mat at a rate that created steel shortages for other programs. Tank production was temporarily reduced because furnaces were prioritized for runway matting. For the Seabees, Marston mat became the weapon that turned construction into a tactical advantage. A 2-man team could carry each panel from stockpiles to the runway edge. Teams worked in assembly line fashion. Position the panel. Tilt it slightly. Slide the hook under the channel of the previously placed panel. Drop it flat. When it seated correctly, you heard a metallic click. That click meant it was locked. At Henderson Field in August of 1942, Seabees laid their first operational Marston mat runway under combat conditions. Japanese bombers attacked daily, sometimes twice daily. The Seabees learned to watch for reconnaissance aircraft. A single observation plane meant bombers would follow within an hour. When air raid warnings sounded, everyone dropped tools and ran for foxholes. The bombers came over, dropped their loads, and left. The Seabees waited 10 minutes for unexploded ordnance to detonate. Then they returned to work. If a bomb hit a section already completed, they simply unlocked the damaged panels and replaced them. If it hit a section not yet completed, they filled the crater with coral and laid mat right over it. By August 20th, just 3 days after the first mat arrived, a section of runway 200 feet long and 75 feet wide was operational. 19 Wildcat fighters and 12 Dauntless dive bombers flew in from the carrier Enterprise that afternoon, forming the famous Cactus Air Force. By September 5th, Henderson Field had a complete Marston mat runway 5,200 feet long and 150 feet wide. Total installation time, including delays from air raids and artillery fire, was 19 days. Traditional concrete construction would have required at least 3 months under ideal conditions. Nothing about Guadalcanal qualified as ideal. The Japanese watched this transformation with growing alarm. Their own construction methods simply couldn't match this pace. When Japanese forces needed to build an airfield on New Georgia Island, they used the same techniques they had used for decades. Large labor crews with hand tools, working around the clock, gradually carving a runway from jungle and earth. It took months. When American forces needed an airfield on the Russell Islands in February of 1943, the situation illustrated the gap. Marines landed expecting heavy resistance, but found the Japanese had evacuated. Within 60 hours of the first troops hitting the beach, Seabees had a fully operational fighter strip laid with mast and mat. The speed shocked Admiral William Halsey when he flew in to inspect. He asked the battalion commander if construction had started before the island was actually secured. It hadn't. The Seabees had just gotten that efficient. The techniques refined at Guadalcanal and the Russells spread across the Pacific. Every island that fell to American forces became a potential airfield site. The Seabees could assess terrain, clear jungle, grade earth, and lay runway matting faster than Japanese commanders thought possible. What took Japanese forces months took American Seabees days or weeks. Munda Point on New Georgia Island in August of 1943 demonstrated the system's flexibility. The Japanese still held positions overlooking the airfield site. Seabees laid mast and mat while under direct enemy fire. Half the battalion operated equipment, while the other half provided covering fire with rifles and machine guns. 14 Seabees were killed and 47 wounded, but the runway was operational in 11 days. Marine Corsair fighters started flying missions from Munda, while Japanese snipers were still being cleared from the perimeter. Bougainville, in November of 1943, introduced prefabrication. Engineers in Australia began pre-assembling sections of mast and mat into giant panels 50 feet long and 15 feet wide. These massive sections were loaded onto landing ships and transported intact. When the landing ships beached at Bougainville, cranes lifted the pre-assembled sections directly onto prepared ground. A runway that would have taken 2 weeks to install panel by panel went operational in 4 days. By December, Bougainville had 3 complete mast and mat runways arranged in a triangle pattern, allowing simultaneous takeoffs and landings regardless of wind direction. The pace of construction had accelerated beyond what anyone thought possible in 1941. Production numbers reflected the system's importance. In 1942, American factories produced 8 million square feet of mast and mat. In 1943, production hit 40 million square feet. By 1944, annual production reached 60 million square feet, enough steel to build a runway from New York to Philadelphia if laid end to end. For Japanese military observers who understood engineering, these numbers represented something more frightening than American carriers or submarines. They represented industrial capacity so vast that the United States could essentially manufacture territory. Every captured island could be transformed into an operational airbase faster than Japanese forces could reinforce or counterattack. Japanese prisoners interrogated throughout 1943 and 1944 repeatedly expressed shock at American construction speed. Multiple reports filed by Allied intelligence officers noted that captured Japanese engineers seemed stunned when shown Seabee operations. One interrogation report from New Guinea in March of 1944 recorded a Japanese naval construction officer's assessment of American methods. The prisoner had watched from hiding as Seabees built a fighter strip on captured ground. According to the translator's notes, the officer estimated the work would have required at least 6 weeks using Japanese equipment and methods. The Seabees completed it in 9 days. The prisoner stated this pace was impossible to match. Japanese forces lacked the heavy equipment, the steel matting, and the organizational system to build at that speed. More significant than the technology gap was the philosophical difference. American military doctrine treated logistics and construction as combat operations, requiring the same urgency and resources as infantry assaults or naval battles. Japanese doctrine treated construction as a support function that happened after combat operations secured territory. This difference meant American forces could build while fighting. Seabees landed with assault troops, sometimes in the first waves. They worked under fire, defended themselves when attacked, and kept building through bombing raids and artillery barrages. Construction didn't wait for security. Construction happened simultaneously with combat. Japanese forces typically secured territory first, then brought in construction units to build facilities after the fighting ended. This sequential approach made sense in a slow-moving campaign. It failed catastrophically in the island-hopping war the Americans perfected. American forces captured islands and had operational airfields before Japanese commanders could organize counterattacks. The capture of Saipan in June of 1944 illustrated this compression of timeline. Japanese forces had built a Sleto airfield on Saipan's southern coast using traditional methods over several months. When Marines captured the airfield on June 18th, just 3 days into the invasion, it was partially destroyed. Companies from the 121st Naval Construction Battalion arrived with the assault forces. Japanese demolitions had cratered the runway. The Seabees found Japanese road rollers abandoned near the site and pressed them into service immediately. They filled craters with coral from stockpiles the Japanese had prepared. Within 48 hours of capture, the entire runway, 150 feet wide and 4,500 feet long, had been repaired. The first aircraft, a Navy torpedo bomber, landed shortly after. The timeline from capture to operational was approximately 2 days. At Tinian Island in July of 1944, the Seabees accomplished what became known as the miracle of construction. 15,000 naval construction workers built what would become the world's largest airbase. 6 runways, each 8,500 feet long, carved from crushed Pacific coral. 12 construction battalions worked simultaneously under Commodore Paul Halloran's unified command. The statistics almost defy comprehension. Seabees hauled, blasted, and compacted enough coral to fill 3 times the volume of Hoover Dam. They moved 11 million cubic yards of earth and coral on Tinian. Stacked on flat ground, this would form a cube more than 6,700 feet in height. Equipment ran 20 hours per day while maintenance crews worked to keep bulldozers, shovels, trucks, and graders operational. By October of 1944, the first B-29 superfortresses began operating from Tinian's runways. These runways would ultimately support 19,000 combat sorties against the Japanese home islands. The atomic bomb missions that departed in August of 1945 left from runways the Seabees had built in less than 4 months. For Japanese military leadership watching this construction pace from intelligence reports and prisoner interrogations, the implications were stark and undeniable. American forces could capture any island and transform it into an operational base before Japanese reinforcements could arrive. Every island that fell accelerated the pace of the American advance. The defensive perimeter Japan hoped to hold was collapsing under the weight of American construction capability as much as American firepower. By late 1944, some Japanese officers were beginning to articulate what the prisoners on Iwo Jima would express explicitly in March of 1945. The war wasn't being lost on battlefields. It was being lost in the fundamental industrial and organizational gap between how the two sides approached the problem of building infrastructure under combat conditions. February 19, 1945. The invasion of Iwo Jima began with the largest gathering of naval construction forces for any single operation in the Pacific War. The 31st and 133rd Naval Construction Battalions were assigned to land with assault troops. Their mission was to repair existing Japanese airfields and support combat operations. What they accomplished would validate every lesson learned since Guadalcanal 30 months earlier. Iwo Jima was 8 square miles of volcanic ash and rock, shaped like a pear, with Mount Suribachi squatting at the southern tip. The Japanese had spent months fortifying the island with a network of tunnels, bunkers, and artillery positions. They understood Iwo Jima's strategic value. Located just 700 miles from Tokyo, the island was close enough that American fighters could escort bombers to Japan, and damaged B-29 seconds could make emergency landings. Japanese General Tadamichi Kuribayashi commanded the defense. He knew he couldn't win, but he intended to make the Americans pay such a terrible price that they might reconsider invading the Japanese home islands. His forces had turned Iwo Jima into perhaps the most heavily fortified island in the Pacific. When Marines landed on February 19th, they faced withering fire from positions the pre-invasion bombardment had barely touched. The volcanic ash beaches absorbed men and vehicles. Tracked vehicles bogged down. Wheeled vehicles sank. Getting equipment inland from the beaches became a desperate struggle. The Seabees landed in the assault waves. The 31st Battalion put 1,000 men ashore by late afternoon of the first day despite heavy casualties. The 133rd Battalion followed. Their casualties were staggering. The 133rd suffered a 43% casualty rate during the battle, losing 430 men killed or wounded out of 1,000. But they kept working. Their first task was clearing the choked beaches. Landing craft were dumping men and equipment faster than it could move inland. The beaches became killing zones, crowded with troops and supplies while Japanese artillery ranged in. The Seabees used bulldozers to carve roads through the volcanic ash, literally pushing vehicles up the slopes from the waterline. They cleared wrecked equipment. They built supply dumps. They strung communications wire, they assembled unloading equipment, and they worked while Japanese mortars and artillery fire fell continuously. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Mount Suribachi dominated the southern beaches, and every American knew that the fortress had to fall before real progress could begin. Marines of the 28th Regiment attacked Suribachi's heavily fortified slopes, while Seabees worked behind them to support the advance. By February 23rd, just 4 days into the battle, Marines reached Suribachi's summit and raised the American flag in what became the war's most iconic photograph. But controlling the summit didn't mean controlling the mountain. Japanese defenders still held positions in tunnels and caves throughout Suribachi's slopes. The artillery spotters and observation equipment the Americans needed on the summit couldn't get there without a road. The existing Japanese paths were barely adequate for men on foot, completely inadequate for vehicles or heavy equipment. The 31st Battalion received orders to build a road to the summit. The mission seemed impossible. Suribachi rose 554 feet above sea level, with slopes too steep for conventional road building. The volcanic rock was brittle and unstable. Japanese snipers still operated from cave positions along the route. Construction would happen under fire with inadequate equipment, while the battle for the rest of Iwo Jima raged. The Seabees started work immediately. They began with reconnaissance, climbing the mountain on foot to identify the best possible route. They marked grades with stakes, planned switchbacks, identified areas requiring cuts and fills. Then they brought up bulldozers and graders. Working in continuous shifts, Seabees carved a road that zigzagged up Suribachi's face. Bulldozers cut into the volcanic slope, creating a shelf wide enough for vehicles. Graders followed, smoothing the surface and establishing proper grades for drainage. Engineers calculated that maintaining a workable gradient required extending the road's total length to approximately 5,000 feet while climbing 400 vertical feet. The average grade was roughly 8%, steep but manageable for most vehicles. Construction crews worked under conditions that violated every safety standard. Japanese soldiers still hiding in caves occasionally fired on the equipment operators. Volcanic ash created choking dust clouds that limited visibility. The fragile rock made every cut unstable, requiring constant attention to prevent collapses. And all this happened while artillery fire from Japanese positions in northern Iwo Jima continued to fall on American-held territory. By March 5th, 14 days after the first Seabees landed, the road to Suribachi's summit was complete. Not just a rough track, but a properly engineered road with established grades, drainage provisions, and an oiled surface to control dust. The road was 35 feet wide with 2 lanes, designed to handle two-way traffic. Vehicles could now transport artillery spotting equipment, communications gear, and observation teams to the summit. Inside the prisoner stockade near Suribachi's base, the Japanese lieutenant colonel stood watching the completed road. He had served 20 years in Japanese Army engineering units. He understood construction. He knew what was possible with the equipment and methods Japanese forces used. He had personally worked on attempts to build a road up Suribachi before American forces invaded. "For 20 years, he told the interpreter, "we tried. You did it in 2 weeks." The translator noted the officer was weeping, not from defeat or humiliation, though both were certainly present. The tears came from recognition. This Japanese engineer understood he was witnessing the fundamental reason Japan was losing the Pacific War. Not American courage, though that was formidable. Not American firepower, though that was overwhelming. The reason was this: American forces could accomplish engineering tasks in days that Japanese doctrine said required months or couldn't be done at all. The road up Suribachi was dramatic, visible proof of American construction capability. But the real demonstration of Seabee engineering prowess was happening simultaneously across Iwo Jima's northern plateau, where the island's 3 airfields awaited reconstruction. The Japanese had built these airfields over months using their standard methods. Motoyama Airfield No. 1 on the southern plateau, Motoyama No. 2 in the center, and an unfinished third strip in the north. American bombers had been pounding these airfields for months before the invasion, cratering runways and destroying facilities. Japanese engineers had worked continuously to repair damage, filling craters, maintaining drainage, keeping at least minimal operations possible. When American forces captured Motoyama No. 1 on February 19th, they found the runway heavily cratered, littered with destroyed aircraft, and mined with explosives. The Japanese had done everything possible to make the airfield unusable. For traditional military engineering, repairing this damage would require weeks of careful work. The Seabees made it operational in days. The 133rd Battalion's airfield detachment reached Motoyama No. 1 while fighting still raged around the field's perimeter. Japanese artillery from positions in the north could range the entire runway. Snipers in bypassed caves took shots at anyone who moved. The Seabees worked anyway. First, they cleared unexploded ordnance and mines. Demolition teams crawled across the runway, probing for buried explosives, marking them for disposal. This was perhaps the most dangerous work the Seabees did on Iwo Jima, more dangerous than working under artillery fire, because a single mistake meant instant death. The teams cleared thousands of mines from Motoyama No. 1, working methodically while combat operations continued around them. Next came crater filling. Japanese and American bombs had punched holes throughout the runway, some 20 feet deep and 40 feet wide. The Seabees used bulldozers to push volcanic ash into the craters, compacting each layer before adding more. Where craters were too large for simple filling, they brought in steel matting to bridge the gaps, essentially creating a suspended runway surface that distributed weight around the damaged areas. Simultaneously, other crews worked on runway extensions and improvements. The existing Japanese runway was adequate for fighters, but too short for the heavy bombers and transport aircraft the Americans needed to operate. The Seabees extended the runway, widened it, improved the surface, built taxiways, and constructed parking areas. The scale of earth-moving was staggering. At Motoyama No. 2, the main bomber field, Seabees moved more than 3 million cubic yards of earth. They used every piece of heavy equipment that could be landed. Caterpillar D-7 bulldozers scarified the existing surface, turning up mines, unexploded ordnance, and shrapnel that was then disposed of. Motor graders followed, establishing proper grades and crowns for drainage. Compactors and rollers packed the volcanic ash into a stable surface. Then came the surfacing material. For the primary runways that would handle the heaviest aircraft, the Seabees laid mast and mat. Thousands of steel panels were unloaded from ships, transported to the airfield, and assembled into continuous runway surfaces. Two-man teams worked in assembly lines, carrying panels, positioning them, locking the interlocking edges together. The distinctive metallic click of panels seating properly became a constant background sound across Iwo Jima's airfields. For secondary surfaces, taxiways, and parking areas, the Seabees used the volcanic ash itself. They discovered that Iwo Jima's ash, when properly graded and compacted, formed a surprisingly stable surface. It lacked the durability of mast and mat, but it was adequate for lighter aircraft and ground traffic. More importantly, it was immediately available in unlimited quantities. The work happened in shifts. One crew operated during daylight, working as fast as possible while Japanese artillery continued to fall. When darkness came, they couldn't use lights that would draw fire, so night crews worked by moonlight or didn't work at all. Then dawn brought the day shift back, and construction resumed. Marine engineers worked alongside the Seabees on Iwo Jima, and the cooperation between services was seamless. Marines provided security for work parties, helped with crater filling, operated some equipment, and fought when necessary. The Seabees returned the favor, distributing equipment and supplies, sharing technical expertise, and occasionally joining the Marines in defensive positions when Japanese counterattacks threatened construction sites. On March 4, 1945, just 13 days after the invasion began, the first American aircraft landed on Motoyama No. 1. A C-47 transport carrying medical supplies touched down, unloaded, and departed. The runway was operational for light aircraft. 2 weeks later, on March 16th, the first B-29 Superfortress made an emergency landing on Iwo Jima. The massive bomber, named Dynamite, was returning from a raid on Tokyo with battle damage and insufficient fuel to reach its home base in the Marianas. Pilot Lieutenant Raymond Malo approached Iwo Jima, not knowing if the island's runways could handle his aircraft. The B-29 weighed 65 tons empty, over 140,000 pounds fully loaded. Nothing that heavy had ever landed on an Iwo Jima runway. Malo had no choice. His fuel gauges showed empty, He committed to landing. The Seabee-built runway held. Dynamite touched down, rolled to a stop, and was quickly refueled. The crew spent the night on Iwo Jima, watched Seabees working under floodlights to extend the runway, and took off the next morning. Malo's landing proved what the Seabees had built could handle the heaviest aircraft in the American arsenal. Over the following months, Iwo Jima's airfield saved thousands of American lives. More than 2,200 B-29 bombers made emergency landings on the island, preserving the lives of approximately 24,000 airmen who would have died ditching in the Pacific. Fighter squadrons based on Iwo Jima escorted bomber raids to Japan, dramatically reducing losses to Japanese interceptors. The island became exactly what American planners envisioned, a mid-Pacific base that made the strategic bombing campaign against Japan possible. None of this would have happened without the construction capability the Seabees represented. Japanese defenders on Iwo Jima fought with extraordinary tenacity. They inflicted terrible casualties on American forces, but they couldn't prevent the transformation of their island into an American base because they had no answer to the Seabees' construction methods and equipment. Captured Japanese documents from Iwo Jima, translated after the battle, revealed what Japanese commanders understood about their situation. Multiple reports filed by Japanese officers during the battle noted American construction speed with what translators described as resignation. One report dated March 8, 1945, stated that American forces were building installations faster than Japanese artillery could destroy them. The report concluded that disrupting American logistics through bombardment was therefore impossible. Another report, this one from a Japanese Navy construction officer captured in late March, provided detailed observations of Seabee methods. The officer had watched from hiding as Americans worked on Motoyama No. 2. He noted their use of heavy machinery, their work organization, their apparent disregard for safety in favor of speed. He estimated that American construction proceeded at least 5 times faster than equivalent Japanese operations. The report included a section on comparative capability that was remarkably candid. The Japanese officer stated that his own construction unit, before being destroyed in the fighting, had comprised approximately 300 men with minimal mechanized equipment. They relied primarily on hand tools and manual labor. The American construction forces, he observed, appeared to have thousands of men and hundreds of machines. He concluded that matching American construction pace was impossible with available Japanese resources and methods. This assessment appeared repeatedly in Japanese military documents from late 1944 and early 1945. Japanese commanders recognized they were losing a construction race they couldn't win. American forces could build faster than Japanese forces could destroy. Every captured island became an American base within days or weeks. The defensive perimeter was collapsing. The fundamental issue was industrial capacity. The United States in 1945 was producing more steel, more machinery, more of everything than Japan could match. American factories built bulldozers, graders, trucks, and construction equipment in quantities that Japanese industry couldn't approach. American shipyards built the cargo vessels that transported that equipment across the Pacific. American training facilities produced the skilled operators who used it effectively. But industrial capacity alone doesn't explain the gap. The Soviet Union had enormous industrial capacity, yet Soviet military construction in World War II was slower and less sophisticated than American methods. The Germans had excellent engineering capabilities, yet German military construction, while impressive, didn't match the pace Americans achieved in the Pacific. The American advantage was systematic. It combined industrial capacity with organizational innovation, good equipment with skilled operators, and aggressive command philosophy that treated construction as a combat operation requiring the same urgency as an infantry assault. Rear Admiral Morel deserves enormous credit for creating the organizational framework that made this possible. His decision to recruit skilled tradesmen rather than training unskilled recruits gave the Seabees immediate capability. His insistence on self-contained battalions with organic equipment meant Seabees could operate independently without waiting for outside support. His cooperation with the Marine Corps in developing combat training meant Seabees could defend themselves and work under fire. The equipment manufacturers deserve credit for developing technologies like Marston Mat that made rapid construction feasible. The steel mills deserve credit for producing millions of square feet of runway matting while simultaneously building ships, tanks, and weapons. The shipyards deserve credit for building the cargo vessels that transported equipment to island after island across the Pacific. And the Seabees themselves deserve credit for working under conditions that would have shut down any civilian construction site. They worked through bombing raids and artillery barrages. They built while snipers fired at them. They operated equipment on terrain that ranged from volcanic ash to coral reefs to jungle mud. They worked in temperatures exceeding 120 degrees in the Marshalls and below freezing in the Aleutians. They endured malaria, dysentery, and tropical diseases that hospitalized 50% or more of personnel at some island sites. The statistics documenting Seabee accomplishments in World War II are almost incomprehensible in scale. The Naval Construction Force, which grew to over 325,000 officers and men by war's end, built more than 400 advanced bases across both oceans. In the Pacific alone, they constructed 111 major airstrips, 441 piers, 2,558 ammunition magazines, 700 square blocks of warehouses, and hospital capacity for 70,000 patients. They built housing for 1.5 million military personnel and storage tanks holding 100 million gallons of gasoline. These weren't crude, temporary facilities. The Seabees were built to standards that ensured durability. When American forces returned to Tinian in 2003 to restore the old Northfield runways, they found the coral surfaces the Seabees had built in 1944 were still largely intact after nearly 60 years of tropical weather. Cleared of vegetation, sections of the original runway proved capable of supporting modern aircraft. The engineering principles were sound, the execution was excellent, and the result was extraordinary. The cost was significant. Over 300 Seabees were killed in action during World War II. More than 500 died in construction accidents. Another 2,000 received Purple Hearts for wounds suffered in combat. The 133rd Battalion's 43% casualty rate on Iwo Jima was exceptional, but casualties were common across Seabee units that worked in forward combat zones. The Seabees accepted these losses as part of their mission. They understood that rapid construction directly supported combat operations and saved lives. Every airfield built meant fighters could provide air cover. Every port constructed meant supplies could reach frontline troops. Every facility erected meant wounded men could receive medical care. Construction wasn't a rear area support function. It was combat engineering that determined whether operations succeeded or failed. Japanese military observers who survived the war and wrote memoirs or gave interviews consistently identified American construction capability as one of the factors that made ultimate victory impossible. Commander Masataka Chihaya, who served in the Imperial Japanese Navy, wrote after the war about the shock of watching American construction on captured islands. He described visiting islands that Japanese forces had abandoned just weeks earlier and finding complete American air bases in operation. The transformation seemed impossible, yet it was happening throughout the Pacific. Chihaya wrote that Japanese planners had fundamentally misunderstood the nature of modern warfare. They had prepared for battles of annihilation where superior tactics and warrior spirit would overcome material disadvantages. What they encountered instead was an enemy who could convert raw geography into operational military bases faster than Japanese forces could react. The Americans weren't winning through superior tactics, though their tactics were good. They were winning through superior logistics and construction, building the infrastructure of Victory Island by island across the Pacific. Major Yoshitaka Hori, one of the few Japanese officers to survive Iwo Jima, gave interviews in later years about the battle. He repeatedly mentioned American construction capability with what interviewers described as a mixture of respect and resignation. Hori stated that Japanese forces knew they were doomed when they saw how quickly Americans converted captured territory into operational bases. No amount of Japanese fighting spirit could overcome that capability. The prisoner who wept while watching Seabees build the Suribachi Road understood this before many of his superiors accepted it. His 20 years of engineering experience gave him perspective that pure warriors lacked. He knew construction. He understood the equipment, methods, and organization required for different types of projects. When he watched Americans accomplish in 2 weeks what Japanese engineers couldn't do in 20 years, he recognized the implications immediately. Japan was fighting a war it had already lost. Not because Japanese soldiers weren't brave or skilled. They were extraordinarily brave and often tactically superior to their American opponents, especially in defensive operations. But bravery and tactical skill couldn't overcome the fundamental disparity in industrial capacity and organizational capability that the Seabees represented. Every island Japan tried to hold became an American airbase within weeks of capture. Every base America built projected air power further toward Japan. The defensive perimeter was collapsing under the weight of American construction as much as American combat power. And there was no answer in Japanese military doctrine or industrial capacity to counter this capability. The invasion of Okinawa in April of 1945 demonstrated the pattern's continuation. When American forces landed on Okinawa on April 1st, they brought 95,000 construction troops, the largest gathering of builders for any single operation in military history. 11 naval construction regiments and 4 brigades, plus 16 Army aviation engineer battalions, worked under unified command. The construction force outnumbered the garrison of many Pacific islands. By August 10, 1945, just days before Japan surrendered, the 85th Engineer Aviation Battalion completed Runway B at Ama Airfield near Okinawa. This 7,000-foot runway was the first entirely American-built runway in the Ryukyu Islands. 5 days later, Japan surrendered. The road to Tokyo had been constructed, literally and figuratively, by engineers and Seabees working under combat conditions across thousands of miles of Pacific Ocean. When Emperor Hirohito announced Japan's surrender on August 15, 1945, he cited multiple factors: the atomic bombs dropped on Hiroshima and Nagasaki, the Soviet Union's declaration of war, the continuing destruction of Japanese cities by conventional bombing. What he didn't mention explicitly, but what Japanese military leaders understood, was that the infrastructure enabling that destruction had been built by American construction forces working at a pace Japan couldn't match. The B-29 seconds that dropped the atomic bombs departed from Tinian's North Field, built by Seabees in 1944. The fighters that escorted bombing raids to Japan operated from Iwo Jima, where Seabees had built runways in March of 1945. The massive logistics network, supporting Allied operations throughout the Pacific, rested on bases and facilities that Seabees and Army engineers had constructed in record time. The legacy of the Seabees extends far beyond World War II. Modern air, Force Red Horse squadrons, rapid engineer, deployable heavy operational repair squadron engineers trace their lineage directly to World War II aviation engineer battalions. The Navy's naval mobile construction battalions continue operating today, maintaining the Seabee tradition in every conflict since 1945. The techniques developed under combat pressure in the Pacific influenced civilian construction for decades. Marston mat found civilian applications after the war. Thousands of tons of surplus matting were used for road construction, bridge decking, and fencing. The rapid construction methods, equipment modifications, and organizational procedures became standard practice in civilian heavy construction. The greatest legacy, however, is the proof that human determination, ingenuity, and courage can overcome any obstacle when properly organized and equipped. The Seabees weren't superhuman. They were ordinary construction workers who found themselves in extraordinary circumstances. They were terrified during air raids, sick from tropical diseases, exhausted from 20-hour shifts. They were homesick and scared. Yet they picked up their tools, operated their bulldozers, laid their steel matting, and accomplished the impossible because the mission required it. The Japanese lieutenant colonel who wept while watching the Suribachi road construction understood what he was witnessing. Not just American engineering capability, though that was impressive. Not just American industrial capacity, though that was overwhelming. He was witnessing the fundamental reason his nation was losing the war. American forces could build faster than Japanese forces could destroy. They could transform geography into military advantage faster than Japanese doctrine said was possible. And they did this routinely, across every theater of operation, in every climate and terrain. 60 years after the Suribachi Road was completed, surveyors measuring the route with modern GPS equipment marveled at its engineering quality. The grades were consistent, the drainage was thoughtful, the alignment made sense given the terrain constraints. This wasn't hasty wartime work that barely functioned. This was professional engineering completed under fire in 14 days. Colonel Peter Jew, commander of the 356th Expeditionary Civil Engineer Group overseeing restoration work on Tinian in 2024, expressed similar amazement at what his predecessors accomplished. He stated that the runways built by Seabees using 1940s equipment under combat conditions were so well engineered that sections remained usable 80 years later. The construction principles were sound, the execution excellent, and the achievement extraordinary. Today, commercial jets land on runways whose design principles trace back to lessons learned on Pacific Islands in 1944. Military engineers deploying to crisis zones use techniques pioneered under fire in North Africa and Normandy. Every time construction forces deploy to build infrastructure in combat zones, they carry forward the tradition established when Rear Admiral Morel created the first construction battalions in 1942. The runways are the monument. From Tinian to Normandy, from Alaska to North Africa, across thousands of miles and hundreds of islands, the runways remain. Some are restored and operational, some are abandoned and overgrown, some are buried under modern civilian airports. But all testify to what American engineers accomplished when their nation called. The Seabees were told to build runways in days in impossible places under terrible conditions. They built the runways anyway, and those runways changed the course of history. They made air superiority possible. They enabled strategic bombing campaigns. They supported amphibious invasions. They evacuated wounded soldiers. They delivered critical supplies to isolated garrisons. The engineers who built them rarely received medals or recognition. Their work was too essential to pause for ceremonies. When the war ended, they returned home to civilian lives, built the post-war suburbs, constructed the highways and airports of America's golden age. They rarely spoke about their wartime service. What was there to say? They had done their jobs. That legacy endures. Every time a military aircraft takes off from a forward base constructed under combat conditions, every time engineers deploy to build airfields in crisis zones, the spirit of those World War II Seabees provides the answer. It can be done. It has been done. And if the mission requires it, it will be done again. The Japanese lieutenant colonel who stood weeping at the fence on Iwo Jima recognized this truth before his superiors accepted it. The war was already lost, not because Japanese soldiers couldn't fight, but because Japanese forces couldn't build fast enough to match American construction capability. That prisoner witnessed the decisive weapon of Pacific warfare, and it wasn't a bomb or a battleship. It was a bulldozer operated by a determined man who knew his work mattered. The runways built in days that survived decades stand as proof that human determination, properly organized and equipped, can overcome any obstacle. The Seabees proved it on island after island, under fire, in terrible conditions, working faster than anyone thought possible. They transformed warfare itself, turning geography into advantage at a pace that redefined the possible. That is the story that must never be forgotten. Not the battles, though those were significant. Not the weapons, though those were impressive. The story that matters is simpler and more profound. Ordinary men accomplished extraordinary things because the mission required it, because lives depended on it, and because they refused to accept that anything was impossible. The road up Suribachi stands as a testament. Built in 14 days, while the battle raged. Built to standards that ensured durability. Built by men who understood that every hour saved meant lives preserved. The Japanese officer who watched its construction understood what he was seeing. The end of his nation's hopes, carved into volcanic rock by Americans with bulldozers who wouldn't quit. Thank you for reading. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.